The order of integration in the integral f is a function of xy and limit with respect to y are as x minus 1 is lower and square root of 1 minus x is square is upper limit and constant limit with respect to x are as 0 to 1. So change the order of integration doesn't mean you directly interchange dx and dy. What is the correct mean of change the order of integration? First we need domain of integration as y limits are given y equal to x minus 1 to square root of 1 minus x square and limits of x are as from 0 to 1. So with the help of this, first draw the domain of integration as y equal to x minus 1. This representing the equation of line x minus y equal to 1. This is the equation of line. And y equal to square root of 1 minus x square. This implies x square plus y square equal to 1. And this is the equation of circle. But this equation saying that this is the equation of circle, upper half circle because y is positive here. With the help of these two equations, first I draw the domain of integration. This is the circle. So upper half circle means this one up above the x-axis and limits of x are from 0 to 1. 0 0 is the domain center of circle and 0 minus 1 1 comma 0 and 0 comma 1. These are the point of intersection minus 1 comma 0. Equation of line, this is the equation of line y equal to x minus 1 or x minus y equal to 1. If I put x equal to 0 then y equal to minus 1. So 0 comma minus 1 is y-axis intercept, and if I put y equal to 0 then x equal to 1. So 1 comma 0 is x-axis intercept. So join these 2 points. So line is like this. Now our region of integration is this as circle, quarter part of circle and this region also. So I call this region R1 and this is R2. Now I need to change order of integration as first dy dx it is given, but I need to change the order of integration, so dx as a first and dy later. With respect to x, so I need a strip parallel to x-axis. So this is the strip parallel to x-axis. It going from this y-axis, it means x equal to 0 to this line, x equal to 0 to this equation of line. This is x equal to 1 minus y. So new limits of x are 0 to 1 minus y and of y are limits of y for r1 minus 1. I change the color of pen. This is the point minus 1 at y-axis to this point. So minus 1 to 0. So limits of y are minus 1 to 0 for r1. For r1, integral translated as 0 to 1 plus y. So this is 1 plus y because x minus y equal to 1. So x equal to 1 plus y. 0 to 1 plus y, and limits of y are minus 1 to 0. For R2, this is R2, this is region is R2. So I cut a strip parallel to x-axis. This is the strip parallel to x-axis. So this is the leftmost part of the strip, and it is going to this curve, x square plus y square equal to 1. So x equal to square root of 1 minus y square, and lower limit will be from 0. So new limits for R2, for R2, new limits of x are from 0 to square root 1 minus y square, and of y are, y limits means limit of y. This is 0, y is 0 here, and upper limit is 1. So 0 to 1. So integral will be 0 to 1 minus y square, and limits of y are 0 to 1. This is f of xy dx dy, and this is also f of xy dx dy. But we need entire region. We need the integral over this entire region. So I add these two, r1 and r2, integral for r1 and r2, integral for r1 and r2. This is equal to minus 1 to 0 and 0 to y plus 1. This is f of xy dx dy plus 0 to 1 and 0 to square root 1 minus y square f of xy dx dy. Now this is the correct way. This is the correct way to change the order of integration. Remember this point, or change the order of integration. It doesn't mean change the partial changes with respect to x and y. This is not correct way. First, find the domain of integration, and in this domain of integration, uh, check what are the changes in limit, and according to them change limits, and find the integral. This is the correct way to change the order of integration.